Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be looking at infinite geometric series. And so to begin this investigation, I wanted to show you the partial sums for each of these series below. So we began by finding just the first partial sum of this first series, which is, if expressed as a decimal, 0.5. The second partial sum, which would be adding a1 and a2, would be 0.75. If we added the first three terms, we'd get 0.875. If we added all four of these terms together, it'd give us 0.9375. If I continued my series out to 5 terms, you would see it to be this 0.96875. And continuing on, we would see 0.984375. Now we could keep going and going and going and finding more and more partial sums, the 7th partial sum, the 8th, the 9th, the 10th, the 23rd, the 32nd, the 100th. But what we're going to notice here every single time is that these partial sums are never going to exceed a value. And what that leads us to discover is that there exists series that approach a particular sum. Those are called convergent series. For this series right here, this series, if you were to go all the way out, even just as far as you possibly could, this series is going to be approaching 1. This series approaches 1. Whereas this other series, let's take a look at it. For the first, if we were to look at just taking the first partial sum, it's 0.5. For 2, it would be 1.5. For these 3 terms, 3.5. For the 4, 7.5. For 5 of them, 15.5. For 6 of them, 31.5. This is not, it's just exceeding, it's just growing and going and going without any boundary. We call that sum a divergent series. And now begs the question, what causes it to be convergent and what causes it to be divergent? When will our series converge? If your series has a rate whose absolute value is less than 1, then your series will converge. It will be convergent. But if your series has an R value whose absolute value is greater than 1, then your series will be divergent. So that ratio really matters. So if it's divergent, we will have to find a finite number that we're adding together in our series. But if it is convergent, you can actually look at finding an infinite geometric series sum. And so here is our beautiful formula for doing that. To find that infinite value where we are looking at finding the sum of all the terms to infinity and beyond, it is to simply take your first term and multiply it by the ratio of 1 over 1 minus your ratio. That is our formula for finding the infinite geometric series. But it must be convergent. Don't forget that this only works if it is a convergent series. So let's determine if these series below are convergent or divergent. Remember, convergent Convergent is when we have those r's that are less than 1, and divergent is when we have our r values that are greater than 1 when you take their absolute value. So let's look at example number 14. If we're going to determine if it's convergent or divergent, we need to know about their r value. That will determine convergent or divergent. So ladies and gentlemen, let me ask you, what is our r value for example 14? What is that r value? The r value here is a -6 each time we're multiplying by -6. So is that a r value whose absolute value is greater than 1 or less than 1? And if so, is it convergent or divergent? Because this r value, the absolute value of it is greater than 1, this is an example of a divergent series. And so we cannot determine the sum unless we were looking to find a sum of just a particular number of terms. What about in example 16? What about in example 16? Can we begin once again by finding our r value? What does our r value equal? Will you guys let me know what that is? The r value here is a -1/2. That is the ratio between our terms. So with that, ladies and gentlemen, I now ask, will this series be convergent or divergent? Because the absolute value of 1/2 is a value that is less than 1, we will have a convergent series. This will be convergent. And that allows us to go ahead and use our convergent infinite geometric series formula to go ahead and find the sum for this series. It would be to take your A1 value, which is right here, and multiply that by 1/1 minus our rate, which is a -1/2. So ladies and gentlemen, using your handy-dandy graphing calculators, will you evaluate what this expression simplifies to? This sum of this series is -120. If you continued adding all the way to infinity and beyond, you would recognize that this sum is just always going to stay right there at that value. It's pretty amazing. What about if we instead have our sigma or our summation notation like we do in example 18? Honestly, this makes it a little bit easier for us because we can really quickly pick out our r value and determine if that r value is going to lead to our series being convergent or our r value leading to a series that is divergent. What is our r value for example 18? What is that r value, ladies and gentlemen? It is 3/4. And so I ask, is this convergent or divergent? This is once again convergent. So we need to go ahead and begin with finding our sums. It's going to be to take our A1, which this actually is our A1. You could also find it by taking and plugging into the formula 1 in place of that K. and that is 224. And then we multiply that by 1 over 1 minus our rate. And will you all go ahead and use your calculator to evaluate that? What is our sum of this infinite convergent series? That is going to be 896. All right, ladies and gentlemen, I ask you last of all, in example 20, this where we are looking at going to infinity, right? Like it's going not just to a particular number. We're not finding our sum at a particular value, but this infinite sum. What is our R value for this geometric series? It is a -7/6. So ladies and gentlemen, will this be convergent or divergent? Convergent or divergent? Now, just because it was a fraction doesn't mean that that fraction is actually less than 1. This is actually greater than 1, and therefore this is a divergent series. If you went in your calculator and typed that in so that you saw it as a decimal, you would see that 7/6 is greater than 1 by just a little bit. And so this is divergent, and we cannot find that infinite sum. It is not possible. That is all for our video today. If you had any questions about looking at infinite geometric series and finding their sums when convergent, will you please take a moment to share those now? And until next time, stay fired up, you guys.